Okay, today we'll discuss exception handling. It's a very important topic. These are broadly the points which we'll cover: introduction to exception handling, the process, how it's being done, the technique, what are the different terminologies used, then class-based exceptions, unhandled exceptions, rethrowing an exception, restricting exceptions, what are the best practices for handling exceptions, and finally, summary about it. So when you are writing a program, then there may be errors. Those errors may be of three types. First is syntax error. Syntax error means the grammar which you have used is wrong and it is caught by the compiler itself at the time of compilation. Then second type of errors are logical errors or semantic errors, we call them. Those are the errors in writing the algorithm, means the algorithm is wrong. Those are discovered at the time of execution of programs. Then there are third type of errors, which are some unexpected situations, right? Those are not syntax errors, those are not semantic errors, but some other conditions which are totally unexpected and they occur and they cause the program to terminate abnormally. A very simple example is you're trying to open a file for reading which doesn't exist. And after opening without checking, you are trying to read from that. That is an exception because the file doesn't exist, you can't read from there. Similarly, if the array bound or array index goes beyond the boundaries, again it is an error. So errors can be dealt at where they occur. It is possible to write very lengthy code for handling errors, but exception handling is a better way. It makes the program clear, robust, and fault tolerant. Means if any error occurs which you can anticipate that this thing may happen, then your program may become fault tolerant to some extent. There is hardly any program which is fully fault tolerant. It's very difficult to write a fully fault tolerant program. So what happens in case of exception handling? We remove the error handling code from the line where the error has happened. We move it to some other block that we'll discuss a little later. So what can be the common failures? When you are using new operator, memory allocation has failed, or you are using a array subscript which is out of bounds, division by 0, it's a very common error, invalid function parameters, arithmetic overflow, like you have declared two integer values and then you are multiplying or doing something with those and it is exceeding the limits of integer. The result is exceeding the limits of integer, then that is arithmetic overflow. And sometimes there may be a problem of disk space. You are writing into a file and disk is full. So these are some of the problems. So the question is, what exception handling will do? It will catch the errors before they actually occur. If you're not catching the errors, the program will terminate abnormally. And you won't be able to know. Sometimes you are not able to know what was the reason. And there are certain errors, some exceptions, which can be handled. And they can either continue the flow of the program or we can terminate gracefully. We can specify that this is the problem, that's why we are unable to continue. Exception handling specially deals with synchronous errors, means which are caused by the execution of program while you are executing the program. For example, divide by 0 or array index is out of range and so on. We'll discuss those a little later. It does not deal with asynchronous errors, which are caused by the operating system or by the hardware, which are beyond the control of program. We call them asynchronous errors. These occur in parallel with and independent of program's flow. These may happen in parallel or they may be independent of the flow of the program. Typically used when error dealt with in different place where it is occurred. As I told you earlier also, we move the code of error handling from the place of error occurrence. We move it to a separate block. That's how we handle exceptions. And then sometimes it may happen that an exception has caused something which cannot be recovered. But in that case, the program should exit or it should shut down very cleanly. If it has occupied some memory, it has allocated some memory or allocated some resources, then those should be freed before terminating the program. But it should never be used. Exception handling should never be used for program control. It's not like any loop. It is not any kind of if-else statement, conditional control. No, it is simply meant for handling those errors which were unexpected. I told you earlier also, it improves fault tolerant. Your program becomes more robust. And since we are separating the error handling routine from the from the source of error, we can write it, we can make it easier to write. We can even specify what kind of exceptions are to be caught. Okay, why do we need it? If there is no exception handling, then what will happen? Suppose array is going out of bounds, or file doesn't exist, you are still trying to read, or division by zero is there. You are not handling any of those exceptions, then unchecked errors, those errors will cause the program to abort abnormally. If there are many if clauses for checking errors, then it will clutter the program. If you're not handling exception, you're trying to handle errors through if-else statements, then it will make your program very cluttered. And sometimes we are using return values to indicate errors, which is also not a good practice. Pass an error label parameter in a subprogram. Pass an error handling subprogram to all subprograms. These will be the problem. The biggest problem is of abortion of the program. The program will be aborted, which is not good. And without specifying any reason, it will abort. But when you are handling exceptions, then the exceptions can be caught and handled, and program may continue. It's not that the program will abort in all cases. We may continue with the program. If exception or the error is minor, we can even ignore it, continue with the program. So it is, though we say that exceptions mean something unexpected, but still we need to anticipate what may happen. Accordingly, we'll program that. So we can handle, we can reuse the error handling, exception handling code. So what are the sources of exceptions? Those may be at hardware or operating system level. For example, keyboard interrupts, network message arrivals, or disk in IO completion. Whenever these things happen, then some interrupts are generated by hardware or the operating system. Then the problem may be at language level, for example, type conversion, illegal values, improper cast. For example, we had discussed dynamic cast. Dynamic cast will cause a problem if it's not properly casted. Bounds violations and illegal array indices, bad references or null pointers. Then there may be problems at program level also. For example, arithmetic exceptions, divide by zero, underflow, overflow, memory access violations. You have allocated memory, and instead of assessing that chunk of the memory which you have allocated, you are going outside it. Or sometimes there is problem of stack overflow or underflow. And there are then user-defined exceptions also. So what are the terms? There are mainly three terms. First is the exception. It is a condition which is unexpected. As I told you, something unexpected has happened, so we need to handle it. Second is exception handling. It is the process of responding to the occurrence of such an unhandled event. It happens during computation of exceptions. Next is exception handler. Exception has happened. Now we need to handle it. So the code that handles that exception is called exception handler. If exceptions occur during execution, we can add exception handling code at point where an error can occur. Program flight code terminated the program, or program terminated with an appropriate error message. We can write the exception handling code at the point of error also, but it is not recommended. If that happens, the remaining statement in that while block are ignored. This is something very important. Where an exception has been raised, whenever an exception is raised, then the exception handling routine is invoked. After handling the exception, the system control or the program control will not come back to the point of exception. It will continue from the exception handler code onwards. I will write a program in this and I'll demonstrate that. If no exception is thrown in a try block, then program will, it won't look for any of the cache blocks and the program resumes after the last cache block. So let us pause here and write a program for this. So I'll create a new project for this. There are three things which are used in exception handling, three terms which are used. First is the try, second is throw, third is catch. Try means you will put whole code, all of that code which may cause some kind of exception in a try block. For example, here, we'll put some code in try block. Suppose I want a positive value. Cout, enter a positive integer. Suppose the program is to find factorial of a number. C in A. If A is greater than or greater than equal to 0, find a factorial. Else, now this is important, throw A. In the try block, we will put, I repeat, in the try block, we will put the whole code which may cause an exception. And if an exception has happened, like in this case, we want all positive integers only for finding factorial because we can't find factorial of negative number. So if it is a positive number, 0 to any limit of that number, then we'll execute this code, find factorial, else we will throw A. Throw means we are throwing the exception. And when an exception is thrown, there should be a corresponding cache block outside the try block. And let me write here, cout reaching here. Let me write here, cout still in try block. What happened? Oh, sorry, it had to be X. Okay. Now what will happen? Have a look. Enter a positive integer. So look at the code. First, this is executed. It will ask enter a positive integer. We have entered a positive integer. It will go inside here. We'll write a statement here. And after that, it is still in try block. It is still in try block because no exception has been thrown. And after that, it is reaching here, which is outside this try and catch block. Let me write a statement here. CL finding factorial. Suppose we have written the code for finding factorial here. Okay, let me just write a function for that. Here we'll compute the factorial. Let me run this program once again. Suppose we want to find out factorial of 10. So it is printing the factorial of 10. It is saying I still in try block because no exception has been thrown. That's why it is writing still in try block. And after that, it is reaching here outside the catch block. This statement is outside all try and catch blocks. What happens in case an exception is thrown? Let's try again. So if I enter -1, what it will do? It will skip this statement. It will not reach here. Since a is less than 0, it will come to else part. It will throw an exception, which will be caught here. And after printing invalid value, it is reaching here. It means the program is continuing even after handling the exception. So that's why exception handling is important. And if suppose this is not there, then what will happen? So first of all, it is a syntax error. Try block requires at least one handler. So there has to be a handler. Now, okay, fine. We have a handler, but I'm making it float instead of integer. Here we are throwing a. A is integer. Here the handler is of type float, which are incompatible. So again, it will cause an exception which is not handled. And you can read the message here. It is unhandled exception, right? So we need to handle it. The type of exception thrown and the corresponding catch should have same types. There should be compatibility. Otherwise, it won't work. Okay. Is it clear?
Yes, sir.
So,
Whatever we have discussed till now, is it clear?
Yes, sir. Yes, sir.
Okay. So we have discussed these three things. Try. Try is the block in which you will write whole of the code, which may cause an exception. If an exception is there, you will use throw, and then outside the try block, you will use catch. Okay. So let us try to throw an exception here. If n is less than 0, throw n. Let's see, does it work or not? I'm not handling it here now. Have a look. It is in try block, but I am not throwing exception here. I'm throwing exception inside the catch block. Now let's try inside the fact function. If it is 10, it will print the value. It will print what is the value of fact. Because no exception has been thrown, it will continue with the next statement in try block, and finally it will reach here. So if it is -1 or any value less than 0, you can see it has thrown an exception. Now in the fact function, there is no catch block, no try block, no catch block, right? But when you are calling this fact, then it must be inside the try block. You cannot call it outside the try block. For example, if I try here, fact sum 5, let's see, does it work? After executing this, since it is a positive value, it will work. If I enter a negative value, if I give it a negative value, for example, -5, see what will happen. Again, it is an unhandled exception because you have called this fact function outside the try block, and inside the function, it is throwing an exception. So if a function is throwing an exception, then that function should always be called inside the try block only. Is it clear, Bache?
So,
Yes, sir.
Okay.
yes, sir.
So what happens? First of all, we'll hit the exception, means we'll find the problem. Next, we'll throw the exception. So hit the exception should be in try block. Throw the exception is again within the try block. Then catch will be outside the try block. We call it catch handlers. And then within the catch block, we will take the corrective actions. We'll handle the exception. So like in this case, this is where we will catch an exception. If an exception is found, we will throw it. We can do it within the try block or from any function called within the try block like here. So we'll throw the exception. Then there should be a handler, catch. This is the handler. And within this, we will handle the exception, right? Or you can give some message here, any kind of message you want, which should be able to convey what is the problem. Now, important thing is there can be many catch blocks. We'll discuss it a little later also. The program searches catch blocks in order, looking for an appropriate exception handler. Like in this case, once again, let me write catch character pointer str cout str, and then so here let us do it once again. If a is greater than equal to 0, then instead of doing anything else, I'll write throw. It's a valid value. Else throw a. Now, whether it's a valid value or invalid value, in both the cases, we are throwing the exception. It means this statement will never be executed. Clear? So what will happen in this case? When we are throwing character pointer, it will be caught here. It will search for corresponding catch block in case of multiple handlers. And if it is found, it will be executed. So for first throw, the second block will be catch block will be executed. For second throw, the first catch block will be executed. Like if I am entering value 10, it is saying it is a valid value, right? So it is printing it here. It is reaching here. We are throwing a character pointer type of exception, which is caught here. And if we are entering the -1 value, it is saying invalid value. It is reaching here, right? So if you are using simple data types, if you are not using inheritance, then the order of cache blocks doesn't matter at all. I repeat, if you are using simple values and you are not using inherited classes for exception handling, which we'll discuss a little later, then the order of cache blocks does not matter. You can write these like this also. It won't make any difference. Is it clear? It's not necessary to
Yes, sir.
write the handlers in the sequence of throwing the exceptions. It's not mandatory up to this point. Okay, let's continue. So if the type of thrown exception matches the parameter type of one of the cache blocks, then code of that cache block is executed. Means that handler is executed. Remaining cache blocks are ignored. Like in this case, if it is throwing an integer or if it is throwing a character pointer, this cache block will be executed. This will be ignored. It will move to the next statement then outside the cache blocks. So this is the flow diagram. A statement throws an exception. Exception handler is there. We'll continue with it, okay? It may be a very long class. So a statement throws an exception handler is there. After that, statement to deal with the exception are executed. It means this part is within the cache block. And after that, statement following entire try catch statement. Means outside all try catch blocks, the statement is there. And if there is no exception thrown, it will straight away go to this. It will skip all the cache blocks. Okay. What is the technique? Programmers can handle any exception they choose. It's up to you which kind of exceptions you can choose. You want to handle, for example, we can handle all exceptions of certain type. For example, you want to handle all those exceptions which are related with values of the data type. Means if they are going outside the range, then you can handle those exceptions, or exceptions of a group of related types. So we have three choices. Whenever an exception occurs, we have three choices. First is simplest one, terminate the program. Second is include code to recover from the exception. And third is log the error and continue. So what happens when we terminate the program? So in some cases, if you know that it is not possible for you to handle the exception, it is better to terminate the program because you can't proceed. So it's a very simple example. If the input file, a file meant for reading, doesn't exist, I think program can't continue. So we'll have to terminate in any case. There's no other choice. The program can output an appropriate error message and terminate. So what we can do, we can write an appropriate error message and terminate the program there itself. I'll show you an example of this. And then because of this, stack unbinding will happen. I'll tell you what is that. It occurs if no matching cache handler is found. If there is no corresponding cache handler to the throw statement, then stack unbinding will happen. Program attempts to locate another closing and closing try block in the calling function. So, okay, let us discuss first stack unbinding, then I'll give you an example of this. Occurs when a thrown exception is not caught in a particular scope. If the exception is not caught, then stack unbinding will happen. I hope you remember I had told you that when a program executes, then every program maintains a stack that keeps the information about the functions being called, the values of variables. It stores the program environment in that, or referencing environment in the stack. I hope you remember that. We had discussed it at the time of discussing recursion. Like when a recursion is happening, when we are using recursion, then when you will make a call to the function, then it will be stored in the stack. The reference environment of that function will be stored in the stack. When you are making subsequent recursive calls, then for each recursive call, a new reference record will be stored in the stack. So stack will maintain the information that when control is coming back, when control is getting out of a function, where should it move to? If it moves to the calling function, then what are the values of its local variables, expressions, and other things? All that information is stored in reference variable or reference record, and it is loaded from top of the stack. So if an exception happens, then stack unbinding is done. Whatever is stored in the stack, that is brought out, and accordingly actions are taken. So all the local variables of the function are destroyed. You just imagine that you are running a program which has caused an exception and program is terminating abnormally. The memory allocated to those local variables, or it may be arrays or pointers, it should also be removed. It should also be freed. So it will also invoke destructors. Control returns to the point where function was invoked. Attempts are made to cache the exception in outer try-catch block, because try-catch blocks can be nested also. We'll discuss it a little later. If the exception is never caught, the function terminate is called. So this is one approach. For example, here, once we have caught an exception here, we can exit from we can write an exit and we will terminate the program. Have a look here. So let me write this exit in both the catch handlers. Whatever is the case, whether it is executing this handler or this handler, control will not reach here. So I am entering 1. It is saying it is a valid value. This statement is not executed, even though it is outside the catch blocks. But because you have written exit 1, the program is terminated. So the last statement will not be executed, and stack unbinding will be done. So this is one alternative, that you can terminate the program. Second is fix the error and continue. You just imagine that you have written a program which is tracking the movement of satellite, right? If there is an exception, would it be advisable to terminate the program? You will stop tracking the movement of satellite? It's not possible.
No, no, sir.
It is not recommended at all that you stop tracking the movement of satellite. So better alternative is handle that exception. Find the error, fix it, and then continue. For example, here, we like in the program here, we want an integer. Instead of an integer, the user is entering a character. So it's a minor error. You can put it inside a loop. For example, here, have a look for or while 1. While 1 means the statement is always true. We'll put full of the catch block, catch and try and catch block in this. So what will it do? It will keep running till the statement is, or till the required value is not found. We can do it here. Cout fact A handle and break. Break means it will come out of the loop, otherwise it will continue. Have a look here. I am entering -1. It is saying invalid value. Oh, just a minute. It has moved out of, should stay within this. If I enter A, it is reaching there. It should continue. Why it's doing this? We are using the loop. It should remain within
So
this.
exit statement भी है ना?
but exit कर नहीं ना रहे हम, यहाँ तो आ ही नहीं ना रहा. It's not reaching here. Let's try it again.
Yes, sir.
And it is coming out. Why? Oh, okay, fine. Since we are finding the value, we are breaking it. We are breaking here. Break means it will come out of the loop, right? Then it is reaching here. But if it is an invalid value, for example, I have entered -1. Again, it is asking for. Now it is working. Enter a positive value. Again, accidentally I entered -10. No, it's not satisfied. It's saying it is invalid value. So it will keep going till we enter a positive value. Is it clear?
Sir.
Right? So you
Yes,
can
sir.
put this code
Yes, sir.
inside a loop. The loop will continue till you get the desired value. So you can include the necessary code to keep prompting the user to input a number until the entry is valid. Third method is sometimes it happens it's not possible for you to handle the exception, or exception has been caused beyond your control because of the circumstances beyond your control. In that case, you can maintain a log of whatever actions you are taking so that somebody else may be able to read that log and can conclude that what was the reason of error. So you can